So let's just do this worksheet here now with a bunch of different problems on derivatives and just the taking of derivatives by these rules we've been looking at. Okay, find the derivative of each function. All right, so I have y equals x to the 6th. So again, I can choose notation, type of notation here. So I'll just say y prime equals, now this is just a power, so use the power rule, 6x to the 5th. Okay. Now I have g of x equals x squared plus 4x cubed. Okay, that can just become g prime of x on the derivative. X squared becomes 2x plus, and then I have 3 multiplies 4 to give me 12. X to the 3 minus 1 is 2. So 2x plus 12x squared. Okay. Now f of s equals s plus 1. So I could do f prime of s, but I'll just switch it up notational wise and just say now df ds equals, okay, the derivative of s. Well, that's just like when we did the derivative of x before under our initial rule. It's the derivative of 1s, so it really just becomes 1. And then the derivative of 1 is 0, so I just get 1 as the derivative. All right, y equals x squared minus 1/2 cosine x. Again, I'll just switch it up and use dy dx. I could have used y prime. So derivative of x squared, 2x, and then I have minus 1/2 as a constant multiple, and then the derivative of cosine x, by memory, is minus sine x. So that becomes a positive sine x. Okay. How about u of r equals 6r minus 5e to the r? Okay, I'll go back to u prime. U prime is then, all right, derivative of 6r. Well, that's just an r to the 1, that's first power, so it's just the 6. The derivative of r with respect to r is 1. Minus 5, constant multiple, derivative of e to the r. Well, the exponential brings back itself, e to the r. Okay. Okay, so this one in F here is a good one to look at, because basically the issue here is it's just not written in a very helpful way right now. It's written in a nice way if I had to plug in a number, but not for taking derivatives. So the first thing I'm going to do is I'm going to rewrite this. Just rewrite it, no derivatives yet. So I'm going to rewrite this as f of x equals x to the 1/2 minus 6x to the 1/3. Okay? Now I'm going to take my derivative. F prime of x is 1/2 x to the minus 1/2, because I did 1/2 minus 1, minus 6 times the 1/3 comes down, x to the 1/3 minus 1, so 1/3 minus 1, 1/3 minus 3/3 is minus 2/3. So that gives me 1/2 x to the minus 1/2 minus 2x to the minus 2/3. Okay? And again, yes, I could change that to positive exponents. I could change that back to radicals. And I might want to do that depending on certain circumstances. But in this case, I might as well just leave it here. I don't have anything else that I'm going to do with it. In particular, if I wanted to do more derivatives, this would be a better form. Okay. All right. Find the slope of the graph of the given function at the indicated point. Okay, so now we have to remember slope of the graph of the given function. That's nothing more than derivative. So I want the derivative at the indicated point. This means just evaluate the derivative at that point. So I don't want the derivative function in the end. I want that function evaluated at whatever point of interest we're looking at. Okay, so here's my function. First thing I do is going to find the derivative. Now again, I'm going to rewrite this. Instead of 3 over x squared, I'm going to write it as 3x to the minus 2. No derivatives yet, just rewriting it. Then I'll take the derivative and get f prime of x to be negative 6 x to the minus 3, because the negative 2 came down and multiplied the 3, and then I did negative 2 minus 1 to become negative 3, and that's my new exponent. Okay, that's not the end of it. And because I'm going to be plugging in numbers, I might think of this then as negative 6 over x cubed. Okay, and so what I want is at this point, but this point has an x value of 1. So really then what I'm going to do is just going to evaluate f prime at x of 1. So negative 6 over 1 cubed, and I get negative 6. So there is the slope of the graph at that given point, negative 6. So let me continue this one with actually a different problem that wasn't mentioned here. So imagine they ask for the equation of the tangent line at that point. Well, I already have that the slope is negative 6, and I have the point 1, 3. So that would be easy enough. Lots of different ways I can do this. I'm going to go and use point slope form. So I could have y minus 3 equals negative 6 x minus 1, or y minus 3 equals negative 6x plus 6, or y equals negative 6x, add 3 over, plus 9. Okay, there would be the tangent line. Yeah, wasn't asked for here, but that's something we also will do a lot of. All right, let's continue with the actual problems here. All right, second derivative of each function. All right, so again, I don't like how this is written, the second part of it, so I'm going to say x cubed plus x to the 1/2. All right, and then my first derivative would be derivative x cubed, 3x squared, plus derivative x to the 1/2 x to the minus 1/2. All right, do another derivative. So this would be 6x minus 1/4 with the minus 1/2 multiplying the plus 1/2, x to the minus 1/2 minus 1 is minus 1/2 minus 2/2 minus 3/2. Okay. So here now, g of z is 2z plus e to the z. G prime of z then is 2 plus e to the z. G double prime of z is 0 because the 2 goes away, plus e to the z. Oh, now this one, I've done what it's been asked for. Now imagine I was asked for the 793rd derivative of g. Well, notice it's just e to the z. So g to the 793rd derivative of g here would still just be e to the z, just to make a point. Okay, good.